Hello, everyone. It's Mr. Kissinger at the Citizenship Academy at Syracuse, New York. This is 5th grade math, module 6, lesson 10. Today we're going to be comparing lines and patterns generated by addition rules and multiplication rules. So we're going to see what addition rules and multiplication rules, what effect they have on points on a line on a coordinate plane. So let's look at our first set of instructions here. It says use the coordinate plane to complete the following tasks. Line P represents the rule X and Y are equal. So you see that starts at the origin down here, and our X and our Y coordinates are equal all the way up. It goes at kind of a 45-degree angle, splits that coordinate plane right in half on the diagonal. And letter B says to construct a line D that is parallel to line P and contains point D. So it doesn't tell us what our rule is yet, but we know that it has to go through point D. It has to be parallel to line P. So it's going to go sort of like this. And we're going to split those boxes at a 45-degree angle. Our angle will be the same, except this one's going to go through point D. So it's going to look kind of like this. And this is line D. All right, so there's D. Name 3 coordinate pairs on line D. And we can kind of just look here. We can go to 1, and it looks like we have 1, 3. So we'll name that first one 1, 3. We'll use point D as one of the points because that's also here. We have 2, 4. And then we have, let's go up here to 4. 4, 6, right at the point of the line up here. Right where the arrow is. Now, if we want to identify the rule that line D follows, it looks as though we have 1, 3, 2, 4, 4, 6. It looks like whatever X is, Y is plus 2. So Y is going to be equal to X plus 2. Now we need to construct line E that is parallel to line P and contains point E. So we're going to make another line here. Parallel. So we're going to cut all of our little boxes here in half on the diagonal, but we're going to go through line E, or through point E, I should say. And line E is going to look just like this. And I imagine that we're going to be doing the same thing for this, or we're going to be finding 3 points that fall on that line. So let's do 2, 1. We'll do a half. There's some halves here. 3.5, 2.5. And then E is 4, 3. So the rule that we're going to see here is it looks like our Y value is always 1 less than our X value. So our rule will be Y equals X minus 1. So if we were to compare and contrast lines D and E in terms of their relationship to line P, well, X plus 2 is parallel, but it's 2 above any point on line P, or any corresponding x value. So any of our x values on line P, the corresponding x value on line D will be 2 more. So if we compare and contrast lines D and E in terms of their relationship to P, they are both parallel. And then corresponding x values on line D are, let's say, +2. And on line E, -1. So it appears as though that when we have addition in our rule, whatever number we add or subtract is going to move our parallel line either up or down, depending on if we do plus or minus. And it says, write a rule for a fourth line that would be parallel to those above that would contain the point 5.5, 2. Explain how you know. So 5.5, 2, well, it looks like we have -3.5. So our rule would be y equals x minus 3.5. Oh, yeah, I'll move that down a little bit. So this is write a rule for the fourth line that would be parallel to those above that would contain the point 5.5, 2. And it says, and I said y equals x minus 3.5, because 2 is 3.5 less than 5.5, and if it's parallel, then we know that it's going to not include any multiplication or anything else. It's just going to be a minus a number, and that will be our rule. So let's move on to the next page. We're going to be doing some rules with multiplication on this one. And it says line P represents the rule that x and y are equal. So again, we have that same line P on here. And this is construct a line V that contains the origin and point V. So let's start with the origin. And here is 0. We'll make a line that goes through point V and through the origin. That's going to be line V. And it asks us to name 3 points on line V. So let's do 1, 2. We'll do 3, 6. And then point V looks like it's 4, 8. Now we have a multiplication rule here, and it looks like x times 2 equals y. So if we want to make our rule, say y equals 2x, or 2 times x. Next, we're going to construct a line W that contains the origin and point W. Our origin, go right through point W. This is going to be line W. And now we have to name 3 points on that line. So we have 2, 1. We have 8, 4. And we have 10, 5. And this time it looks like our rule will be our x value, half of our x value is going to equal our y value, or our x times 1/2 will be y. So y equals 1/2 x. So it says compare and contrast lines V and W in terms of their relationship to line P. Well, they're not parallel, but line W is lower on the coordinate plane relative to line P, and line V is higher on the coordinate plane. And they both go through the origin as well. All 3 of them go through the origin. So I'll put that down here. All go through origin. That's where they intersect. What patterns do you see in lines that are generated by multiplication rules? Well, it looks like the way that we multiply, they're all going to go through the origin, but the larger the number that we multiply by, the steeper that line is going to be closer to the y-axis. So the larger, use the right word here, the greater the number, really. The x is multiplied by, the steeper the line. All right, and that's where we're going to end for today. Thank you guys for tuning in, and I look forward to seeing you next time.